Okay, here, Tim Bolger.
Good evening and welcome to the College of Complex. Let me get this on slide 1 first.
Hey, you stole my graphics.
Yeah, Charlie, I did see your graphics because they were conveniently reusable. You want to go ahead?
You stole it.
I know a good patent and trademark attorney.
Environmentally friendly.
If our esteemed speaker is ready, where
I'm all
is
set.
Why
is he right here?
This is our speaker, and Professor Tim Bolger.
Professor.
He forgot Toastmaster Extraordinaire too. All right, tonight my talk is going to be about the scam of renewables. Why wind and solar power is simply not going to get us off oil. And that it's going to be in all of the above energy strategy. I am not here to knock wind and solar. It has a lot of advantages in limited applications, but it's not going to be the mainstay big power source that you're going to be thinking that it's going to be. Although there has been a remarkable growth in the industry, there are several downsides to it that I'm going to point out here tonight. The first thing is I want to talk about is how many of you drive a car or turn on a light every day? How many of you are willing to give up the lights and some of this other stuff?
I want to move back into trees.
Or how about there's something even bigger, a washing machine? How many of you do your laundry by hand?
Me, old-fashioned sometimes.
Sometimes. Isn't it a lot better when they invented the washing machine? Lighting, drudgery, entertainment. Electric power for the last 100 years has done one thing, and it's freed us from drudgery. It's given us time to do things, and it's provided a lot of entertainment. And if you're expecting people in the developed world not to want this, you're crazy. So what this basically means is that people want power. So as Charlie often says, power to the people. And I'm hoping to show you a way tonight to bring lots of power to the people. The other thing that energy is used for is in communications and internet usage. Are you guys, any of you, aware of how much power our communication and telecommunication infrastructure uses? For example, how many of you guys are familiar with what's called a data center? Okay, how many of you actually been to a data center? And you can see they are vastly big, powerful areas that use lots of power. And this power has to be clean power. It has to be consistent. It has to run reliably. And it can't be interrupted because of the data that's consumed. Not only that, but you have a vast infrastructure of fiber optic cables. It has been said that when you watch an 8-second cat video on YouTube, in the aggregate of power usage, it's the equivalent of driving a car almost 100 yards at 30 miles an hour. So, when you think of this green infrastructure, it's actually not as green as you think. It might be easier just to use that piece of paper. Could it be, with the prosperity electricity provides, that we are simply using too much of a good thing? Can we restrain its growth? Or do we generate it by other means? I tell you, some of you environmentalists out there, as well as other people, this is a really true Faustian paradox. I'll repeat it again. A really true Faustian paradox. I'm going to get into a little bit now about what the electric power does and how it impacts upon society. We have global environmental problems mounting. We have global environmental problems mounting. We have global warming. We have our polar bears and everybody else not doing so well. And of course, we have wars over resources. In a book called Dennis Meadows' Limits to Growth, he showed the effects on finite resources. We have industrial output over here, pollution going up, and industrial output going down if we go on a finite resources scale. However, what happens when you develop is population gets stable in developed nations. And this is very simple why it happens. When kids are no longer viewed as a source of labor, it just gets to be an expense to raise them, you know? I mean, you're not going to have more than 1 or 2 kids. We all love them to death, but you're not going to have 8 or 9. It costs almost $250,000 to raise a kid up to age 21 with education and everything else. And of course, they don't leave the home anymore at age 18 or 19. It's 21, 22, sometimes 30. So it gets to be quite a bit expensive to raise a child when you get into an industrialized economy. So this means the population gets down and generally gets a little bit more stable. We had 6.9 billion people in the year 2010. Prosperity also stabilizes the population. There's only 82 nations now with populations over 10 billion people.
10 million.
10 million. And you have a stable replacement rate of about 2.3 children per woman. And when you have prosperity, roughly about what the CIA World Factbook calls about $8,000 a year, your population tends to go down and stabilize, which basically means that just in the last quarter century, one of the biggest trends that you're going to be seeing around the world is an aging population, meaning that the world's going to be getting, as an aggregate, older. Prosperity also depends on energy. As you get more prosperous, those nations with over 10 million people get a little stable with annual aggregate incomes of over $8,000 a year. Electric power flows roughly good. And of course, there's a lot more that goes into a stable political system, such as rule of law and good governance and lack of corruption and somewhat of a stable population. However, in order to do this and to keep this prosperity and this energy cheap, energy and coal use is growing rapidly in developing nations. And it's not going to stop. If we don't find an alternative that's cheaper than coal, they're going to keep using coal, and we're not going to really solve our global warming problem. The non-OECD energy use is still rising. World coal use is still rising. And again, it's not going to stop because coal still is the cheapest way to generate power. And the funny thing is, conservation is not going to stop this growth. Even if the U.S. cuts per capita energy use in half to 6,000 kilowatt hours per person per year, we'll see a downtrend. Here's the clincher though. If the rest of the world adopts a conservation strategy, we're still going to see an incredible growth in energy usage. So the problem really is how are we going to get this cheap energy? Technology policy lies at the core of our climate change challenge. If we try to reduce emissions without a fundamentally new set of things taking in economic growth, we're toast. All right, now what I'm going to do is just get into a little bit of the background and a brief review of our what is basically the grid or the electrical transmission system around the world. Power usually starts out at a centralized power station. It goes over a lot of large transmission lines to a substation home, out onto the various lines around the neighborhood, and then out to the homes. I did a little something about my own home in Algonquin. In East Dundee, Illinois, which is about 10 miles from my plant, there's what they call a peaking facility, and it runs on natural gas. Basically what this does is if I can't get power from the main line because there's so much more being used, they're going to kick in this natural gas plant and generate power close to me. That power then goes to the Algonquin Road neighborhood substation where I'm at. If you look behind these trees a little bit, you can see some of the electric transformers that are taking the power from the main lines to the neighborhood power lines. And then if you go down further, you can then see the Webster Street line transformer that's just outside my home. There's thousands of these things. And it really does something else. And then finally, it gets into the service entrance of my home. Okay, I'm sure you know what a lot of are thinking. What does my house look like?
Yeah.
There it is, my home. It's a little apartment above a garage. It's my humble abode.
What a dump.
No personal attacks.
The nearest wind farm near my home is in the Lee DeKalb Wind Energy Center at Lee and DeKalb County, which is over at least 100 miles away from my house. It generates roughly 233 kilowatts of power and is only effective about 5 to 15% of the time. In order to back it up, they're going to need a complete natural gas peaking facility behind it. The funny thing is, when you look at the Illinois net electricity generation by source from November of 2013, you're going to find that down at that bottom part of the chart is other renewables. That's natural gas. That's our coal-fired power plants. And that's our nuclear power. In order for renewables to really cut out oil, it's got to get so big to surpass these three growths. In other words, we're like France that gets almost 80% of its electric power from the grid. It's because we're in northern Illinois and we have a lot of nuclear power here. C'est la guerre.
Is that French?
I guess it's French. Vive la France. Illinois energy production estimates for 2011 were basically this. The production came from coal, not much from a marketed natural gas, crude oil, nuclear electric power, biofuels, and other renewable energy. In short, we still have a big infrastructure that uses a lot of coal, a lot of nuclear power, crude oil, natural gas, and yes, our alternatives are starting to come online, but there's no way that they're going to replace oil in the next 20 to 30 years because of what's already there. Illinois is a key transportation hub for crude oil and natural gas moving throughout North America, and over a dozen interstate natural gas pipelines run through the state. Several petroleum and petroleum product pipelines also run through the state, as well as an oil port. If you just look at the city of Chicago at their port area, you'll find a large infrastructure for the transfer of oil. In 2012, Illinois ranked second in the nation in recoverable coal reserves at producing mines. And with a production capacity of 1.5 billion gallons per year, Illinois is a top producer of ethanol. It ranked third in the United States in 2011. Illinois also ranked first in the nation in 2013 in both generating capacity and net electricity generation from nuclear power. generation from its nuclear power accounted for over 12% of the nation's nuclear power. And remember, Shippingport, the first atomic reactor, was only in 1958. And in less than 30 years, look how fast nuclear has grown. Annually, Illinois households use 129 million BTUs of site energy per home, 44% more than the U.S. average. Lower utility bills compared to states with a similar climate coverage result in Illinois households only spending 2% more for energy than the U.S. average, according to the EIA's residential energy consumption key. All this information was last updated on March 24th and is from the source of the U.S. Energy Information Administration. With the cost of construction, the amount of land use, transmission lines cost, and other factors will make impracticable as a replacement, wind as a replacement for fossil fuels anytime soon. And if you look a lot around in Michigan and Wisconsin, where they put up a lot of these large-scale wind turbines, they're the equivalent of 30-story buildings going up all over the place. And they do make noise, they do make low-frequency things, and it divides communities because a lot of people just can't stand the views of the obstruction or the noise that's generated. And a lot of wind has been going in, but there has been a lot of community opposition. And with the amount of land usage required, because wind is so diverse, and the simple fact that you have to have a full-scale backup plant when the wind doesn't blow, it's almost like wind has to go on top of an already existing infrastructure at almost double the cost. Now let's talk about coal for a little bit more. We all know it's a dangerous polluting source of things, but there are some relative advantages. Worldwide coal burning rates that are come out at about 250 tons per second. And there are currently about 1,200 coal power plants currently planned worldwide. That roughly means 8 billion tons of coal smoke are being burned every year.
Oh, that's cool.
That means 22 million tons per day. Coal use is decreasing in the U.S., but rapidly increasing everywhere. And one new major coal plant goes online per week in China. That's how much coal is being used to give power to the people. The toll from coal, in a major study by the Clean Air Task Force, means there are about 13,200 fatalities per year estimated in the U.S. in 2010.
Do you want me to take that away?
About 1,100 fatalities per month. 36 fatalities per day. And it is down from 24,000 in a year in a 2004 study with improved scrubber technology. But the global death rate from coal is much higher, 1 million per year estimated. However, coal is far better than nothing. We cannot afford to shut down coal or drive the cost way up with regulation until we have an economical replacement. Without reliable electric power, we would have a third world standard of living, and electricity from coal still saves far more lives than coal pollution takes, as well as providing us with innumerable benefits. As I said, the generation of electric power, along with its resultant benefits and its environmental degradation, is truly a Faustian
Why
bargain.
are you a Diet Coke?
What about solar power? Only 0.01% of the U.S. electric power is available in 2012, and that's not including non-rooftop solar voltaic and thermal power. The capacity factor for solar power plants is about 10 to 28%. That means it only runs about 10 to 28% of the time because of the nights and the clouds that come in. A solar farm of 1 gigawatt with average power takes 20 to 50 square miles of land. And that means 1 gigawatt being about the size of what it would cost to power an average city of about 50,000 people or less. So it's incredibly land hungry because solar, even though it's free, is a widely dispersed power source and needs to be, a little bit more efficient. That's not to say that solar does not work. But for large-scale power generation, it's not the way to really do it because of the amount of land that's going to be needed. And with that land, you're going to need infrastructure, you're going to need cables, you're going to need power poles, you're going to need transformers, and roads. The thing is, with the huge amount of raw materials and even the huge amount of toxic chemicals that are used on solar panels, and it's 40 times the land that a 1 gigawatt nuclear plant would use, to me, it can be put on buildings and over parking lots, but still, it's going to require a lot of square footage of land or rooftops or whatever to really even come close to producing as much power as coal or natural gas does. It's also more expensive than coal and gas, and many utilities are forced to buy the solar power at retail rates and then to pass along a cost. It would be the equivalent of you going to your store and having the produce bought from your local garden at the retail rates that people are paying for it. It really is good for remote off-grid sites, but not for large-scale energy production. Capacity ratings for wind and solar can be misleading. Capacity factor is the ratio of the average power generated to peak rated power. Wind capacity factor ranges from 15 to 40%, meaning that only 15 to 40% of the time that wind plant is actually active. Solar capacity ranges from 10 to 28%, depending on location, accounting for night, sun angle, clouds, dirt, and etc. However, even though many of you may think it's dangerous, nuclear power does have a capacity of running well over 90% of the time.
Which is 10% I'm worried about.
The cost of energy conversion, even though the sunshine and wind are free, but conversion to electricity is expensive in terms of money, labor, land, raw materials, and environmental degradation. And proponents emphasize the free part, but seldom mention the high conversion costs that are affiliated with wind and solar power. Since the load must be balanced on a continuous basis, units whose output can be varied to follow demand, and that's called dispatchable technologies, generally have more value to a system than those whose operation is tied to the availability of an intermittent resource. In other words, what this means is that we all know that more power is used in the evening than in the morning. We all know that peak power usage is done at about 2 to 3 in the afternoon when all the air conditioners are running. So you really got to kind of watch the flow of electric power with the source. Now what happens if the wind dies down at 3 o'clock? You got to kick up the backup natural gas just to meet current demand. Meaning that dispatchable means you can control the amount of output
Would you like fruit?
from the power plant as demand rise or fall. The thing is, we don't have yet sufficient storage technology in the form of battery power that will bring wind and solar to this point. Although it may be coming with some of the newer technologies on the road, and we've already seen an incredible growth in the wind and solar industry that they are somewhat mainstreamed, they do cost. We've already just seen at the beginning of many of these things the high cost of wind power, and I don't know if many of you have been to downstate Rochelle. They look really good from a distance. You got this nice romantic power size of windmills going everywhere and the renewable energies making everything in, but remember, when it's only being used roughly 18% at a time, your other 80% is still being generated by coal, natural gas, oil, or other dispatchable sources. The cost per kilowatt hour is not directly comparable between dispatchable, contingent, or intermittent resources. Now, we've been over this before. Large energy storage is not yet efficient or economically practicable for wind or solar. Wind and solar power need full capacity backup when the wind shines and the sun don't shine. Capital costs of wind and solar farms are in addition to the cost of the backup dispatchable power plant. Backup power is less efficient with a partial or rapidly varying load. How many of you have been stuck in traffic, stopping and starting in your car, versus driving at a steady speed along an expressway? When you take a look at some of these peaking facilities with natural gas, when a lot of the wind turbines and the solar panels go online, and they have to continually vary their load, you're actually burning, on a net result, more in fossil fuels than you would be if you did not have the wind and the solar plants going online.
You want me to take
Basically,
a
what you're doing is you're putting all these power plants into what we call a
Yes, the double burger.
traffic mode of starting and stopping, depending upon the power. And it's just not as efficient as if they were just running a steady state. So my question to you is, facing with this wind and solar power, the Faustian bargain of these power plants, what are we to do? Is there anything that's going to take us out of this dilemma? You know, I think we're kind of looking at our energy production in the wrong way, with a largely dispatched, widely diverse power source. I think what we're really looking at is just a way that we produce power in the wrong kind of way. If I could tell you that a substance contained in this glass could contain your entire energy output for a lifetime, would you believe me? You know, I was looking at this and I sort of had an epiphany moment when I took another look at nuclear power. What I found was that if with the right type of reactor and the right type of power, that you could put your entire lifetime's worth of energy into a glass just about this size, that tells me something. And it's not too hard to put 30,000 1 million of these into a small building?
It doesn't run.
There is an answer. That little ball could represent your entire lifetime's worth of power. Fantastic or preposterous. I'm going to play for you now a short little 5-minute video that kind of explains where I had my epiphany moment for the resumption of nuclear power from. It's a very short video, it's about 5 minutes long, and just let me get it going here.
That's how much time you got to get away. When they explode.
It's only about 5 minutes.
Oh, thank you. She can read it down.
Water reactor will use about 0.7% of the uranium's energy value, and the light water reactor will use about half of 1%. They both do terrible. At normal pressures, water will boil at 100 degrees Celsius. This isn't nearly hot enough to generate electricity effectively. So water-cooled reactors have to run at over 70 atmospheres of pressure. You have to build a water-cooled reactor as a pressure vessel. The number one accident people worry about, pressure is lost. Water that's being held 300 Celsius flashes to steam. Its volume increases roughly by a factor of 1,000. If you don't get emergency coolant to the fuel in the reactor, it can overheat and melt. This is what drives the design of this building. So if this happens, all of the steam is captured in this building. Now the reactors we have today use uranium oxide as the fuel. It's a ceramic material, chemically stable, but not very good at transferring heat. If you lose pressure, you lose your water, and soon your fuel will melt down and release the radioactive fission products within it. So they have a series of emergency systems designed to always keep the core covered with water. We saw the failure of this at Fukushima Daiichi. They had multiple backup diesel generators, and each one probably had a very high probability of turning on. The tsunami came and knocked them all out. And people sometimes say, is nuclear energy safe? The first thing I said, which one? Thousands of different ways to do nuclear energy. Is the car safe? Well, which one? I had the good fortune to learn about a different form of nuclear power, the liquid fluoride thorium reactor. We can fully burn up the thorium in this reactor versus only burning up part of the uranium in a typical light water reactor. It's not based on water cooling, and it doesn't use solid fuel. It's based on fluoride salts as a nuclear fuel. You have to heat them up to about 400 degrees Celsius to get them to melt. But that's actually perfect for trying to generate power in a nuclear reactor. Here's the real magic. They don't have to operate at high pressure. They don't have to use water for coolant, and there's nothing in the reactor that's going to make a big change in density. Unlike the solid fuels that can melt down if you stop cooling them, these liquid fluoride fuels are already melted. In normal operation, you have a little piece of frozen salt that you've kept frozen by blowing cool gas over the outside of the pipe. If there's an emergency and you lose all the power to your nuclear power plant, the little blower stops blowing, the frozen plug of salt melts, and the liquid fluoride fuel inside the reactor drains out of the vessel through the line into another tank called a drain tank. In water-cooled reactors, you generally have to provide power to the plant to keep the water circulating and to prevent a meltdown. But if you lose power to the lifter, it shuts itself down all by itself without human intervention. A staggeringly impressive level of safety, even if there's physical damage to the reactor. Thorium is a naturally occurring nuclear fuel that is 4 times more common in the Earth's crust than uranium. It's so energy dense that you can hold a lifetime supply of thorium energy in the palm of your hand. We can use thorium about 200 times more efficiently than we're using uranium now. Because the lifter is capable of almost completely releasing the energy in thorium, this reduces the waste generated over uranium by factors of hundreds and by factors of millions over fossil fuels. We're still going to need liquid fuels for vehicles and machinery, but we can generate these liquid fuels from the carbon dioxide in the atmosphere and from water, much like nature does. We can generate hydrogen by splitting water and combining it with carbon harvested from CO2 in the atmosphere, making fuels like methanol, ammonia, and dimethyl ether, which can be a direct replacement for diesel fuel. Imagine carbon-neutral gasoline and diesel, sustainable and self-produced. You can see that uranium-235 is like on par with silver and platinum. Can you imagine burning platinum for energy? And that's what we're doing with our nuclear energy sources today. We're burning this extremely rare stuff, and we're not burning thorium. Some people are kind of environmentalists, they say, listen, nuclear power is not sustainable. We're going to run out of uranium. Okay, I will yield that point to you if we're talking about today's nuclear technology. In 2007, we used 5 billion tons of coal, 31 billion barrels of oil, and produce the world's energy. So I have a friend who's trying to start a rare earth mine in Missouri. Jim, how much thorium do you think you'll be pulling up a year? He goes, I think about 5,000 tons. 5,000 tons of thorium would supply the planet with all of its energy for a year. He goes, and there's like a zillion other places on Earth that are just like my mind. It's a nice mind, but it's not unique. It's not like this is the one place on Earth where this is found. Every time mankind has been able to access a new source of energy, it has led to profound societal implications. Human beings have had slaves for thousands and thousands of years. And when we learned how to make carbon our slave instead of other human beings, we started to learn how to be able to be civilized people. Thorium has 1 billion times the energy density of a carbon-hydrogen bond. What could that mean for human civilization? Because we're not going to run out of this stuff. We'll never run out. It is simply too common.
And that's what thorium's about. It's the Faustian bargain that I'll be finished in a minute.
No, can you tell us, what was the name of the guy with the glasses? In
His
that
name was, you mean the one, his name was Kirk Sorensen.
Yes, sir.
He is now the executive of a company called Flibe Energy Systems.
Fly by night.
I'll get more into him in our Q&A period,
Want
okay?
some roll? You still hungry? You want some soup? Broccoli? Delicious.
Fly by night energy.
I did have a few more graphics, but I think at this point, seeing as how I kind of started learning about this stuff myself over the last 3 or 4 years, I thought at first, this is absolutely preposterous. Nothing could replace or answer this current energy dilemma that we're having. But when I really started looking into this stuff, and I started seeing what it could do to power our planet, the inherent safety in these liquid fluoride thorium reactors, the amount of power per square foot that these things could do, I am fully convinced that this is going to be the way forward for our energy production. The point is that what you guys may not realize is that this thorium revolution is already happening in a place called China. During the 1960s, we did a lot of basic research into the liquid fluoride thorium reactor from under a gentleman by the name of Alvin Weinberg, who in the mid-1970s was fired for mentioning the safety issues of concerning the light water reactors. The biggest thing was that very recently the Chinese all came in, looked up all those source documents that were involved in our research of the 1960s. They now have the son of the former premier of China heading up their thorium energy power. And if we don't get our acts together, we're going to be buying our thorium power from the Chinese. So it took us, the Russians, launching Sputnik to really get our space program going. Many of you here can probably remember the International Geophysical Year that resulted in a large-scale deployment of science and technology to our classrooms. In the large-scale deployment of, let's get a man to the moon. Can the U.S. still do these things? I believe we can. But it's up to this next generation to do it. We baby boomers have become complacent. We baby boomers have started to think of ourselves settling back a little bit. There's a lot of problems out here, but many of us basically need to say, hey, we have to get serious again. We got to bring our country back up to snuff. And I honestly think that if we can provide the world with an answer to its energy problem, cheap, low cost, cheaper than coal, I think we may be on our way. I will now take your questions.
Yeah, let them,
Okay,
I see Michael Cube has his
okay,
hand high. I see several other.
all right, we'll just, Ram, I can point them out. Let's start with you.
How much would it cost to build a thorium plant, various sizes, and would it be possible to build one, say, for like, say like a factory, even a home?
Well, I don't know about too much about the home factors involved, and there is readily available information on that topic from the Thorium Energy Alliance website. I could go online right now and pull it up, but there have been a lot of studies done on the cost estimates of thorium power, and they're generally in line to be a little bit cheaper than coal. If you look at a book by a gentleman by the name of Richard Hargraves, who I took a lot of these slides from, he outlines very thoroughly the case for thorium power reactors being actually much cheaper than coal and much more done. The big thing that's holding them back right now is the nuclear industry itself, because there's a lot of money to be made in the reprocessing of fuel. And remember, the first cost people in innovation always usually get things. Is Windows our best system for operating a computer? Probably not, but all the first costs were done and deployment costs were done by Microsoft, and we're using them as habit. And the thing is, it's the same thing with the nuclear power industry. We had basically what the world is running on right now, and there hasn't been any development for 30 years in the power industry because of some of the things that happened at 3 Mile Island and Fukushima and other places, that, you know, it's sort of like using a mainframe computer from the 1970s to power the internet. All right.
Judy Cradaville.
Judy?
Yes, I'm wondering, you talked about not regulating out of existence coal and these other things. Well, what about regulating to clean up the pet coke and the coal ash that these plants dump in our rivers?
You know, one thing that that coal enjoys right now, and this is something that needs to be figured in, I'm a free market guy. I like free markets, but the price has to reflect the externalities of the system. Right now, a lot of the coal companies are not being charged for those externalities, like the cost of cleaning up the environment, the cost of getting things in. As a matter of fact, coal smoke has more fission products, meaning radioactive isotopes, that emit from its smokestacks than you would see from a nuclear power plant. The only reason that coal, if they were as highly regulated as the nuclear power plants, coal power would be shut out of, basically run out of business. Did I answer your question?
No.
Okay.
We need to clean up all the waste products from nuclear too, and we don't spend the money to clean it up. What would you suggest in doing that?
Thorium power also has the capacity to burn up the present nuclear waste. And a lot of that nuclear waste is not waste. Remember, we're only burning about 0.3 to 0.5% of the fuel that is already in a lot of these waste products. So you still got a whole lot of power that can be regenerated. You throw these waste products into a lifter or a liquid fluoride thorium reactor for about 30 years, you'll see most of those long-term radioactive isotopes burned.
You showed, okay.
Yes, Don.
Okay, Tim, in that little show that you showed there with that man speaking.
Yeah, that's Kirk Sorensen.
Right, and you showed the lifter, and he was talking about, I wanted to ask, and he showed these diagrams of how this thing would work. Are there any thorium nuclear power plants online right now?
At this point, no.
Okay, why not?
Because the technology right now, the concept was proven in the 60s. They ran an actual liquid fluoride reactor for well over 6,000 hours. And the government, roughly in 1973, shut the program down because they were wanting to go with the liquid sodium breeder reactor program. As a matter of fact, the guy who fired him was a congressman by the name of Chet Holyfield. And what happened under Chet Holyfield, they spent $2 to $3 billion to get this monstrosity breeder reactor running. Now, because that technology was killed, and most of the nuclear establishment is already using U-235, that's one of the reasons we don't have these plants going. What basically needs to happen is that these plants need to be researched a little bit more, and they're talking about within 5 years having the first commercially available thing developed. It's a matter of now just some metallurgy and some other minor details that they've been working on, but it's just a matter now of getting the funding from, you know, the government or some other sources. And there are private equity funds doing it right now. Flibe Energy under Kirk Sorensen is seeking right now to build the first liquid fluoride thorium reactor.
The real free follow-up to this, why, I'm a little confused here, why did the government stop funding this project?
Because basically the only people doing reactor technology at time was at Oak Ridge National Laboratories. And the only people who really knew about nuclear power in the form of liquid fluoride reactors was that group of scientists. And you also have to remember that the biggest force in the early days of nuclear power was a gentleman by the name of Admiral Rickover, who was still in the Department of Defense during the Reagan administration, and he was adamant that every reactor could be made and ran safely on uranium-235. And now, because of the large reprocessing contracts that are involved to get the pelletized uranium fuel going, the large infrastructure, that once these plants are built, it's like, hey, just let's let the cash roll in and we're fine. And there's a monopoly power, and the thing is, nobody's really done it yet because it's still been around since the 60s, but people basically forgot about it. These scientists at Oak Ridge basically retired. They were stifled by the government. The government did not want to do this. The Nuclear Energy Administration is basically taxed with one thing: nuclear weapons.
Can you make nukes with thorium?
Uranium-233 has been exploded in a bomb. Uranium-233, which is what these reactors would run on, is a fissionable material and can be made into bombs. The thing that's nice about it is that there's a little something called uranium-232 that goes along with it. So if you have this cake of uranium-233 in a liquid form, it is really nasty stuff. I mean, you know, if we deploy these reactors, you're still going to have a building about the size of this restaurant powering the north side of the city. It's still going to contain nasty stuff. I'm not saying that it's perfect, but compared to having a building full of nasty stuff for about 30 years and saving all that carbon pollution with the coal smoke and the tons and tons of stuff we put into the air that's inevitably going to be produced anyway, I would much rather see that nasty, nasty stuff in that one building for that long and powered.
Karina Shoshan?
Yes, Karina.
I was confused. There was one slide and it said that Illinois uses 44% more oil than,
No.
I mean, more energy, more BTUs than the rest of.
Yes, most of that stuff was directly from the website. Now you also got to remember, Illinois uses it more because, not in residential, we also have a lot of industry. Okay, when we get a little bit more details, I'll take the question for you offline and we can take a look at what you're talking about. Or I can pull up the presentation right now and find out what slide you'd like to use.
All right, yeah, it was one of your earlier slides. It had Illinois. You were talking about the state of Illinois and
Okay.
statistics with Illinois, and
Let me pull it up.
Illinois was using more, 44%.
Yeah, 44% more energy than the U.S. average.
Why? Why are we using the?
Industrial use.
Yeah. Paul's going to get the projector on. We'll get that slide back up so we can answer your question more better.
You like to watch a lot of TV.
More than North Dakota,
I'll try to pull the slide up for you now, Karina.
Yeah, but we're right next to each other.
Use it year round.
Okay.
Illinois, okay, the next slide, I think. Annually, Illinois households use 129 million BTUs of site energy per home. 44% more than the average, US average?
What, well, to be honest with you, Karina, I was a little bit taken aback with the figures too. And the source is the U.S. Energy Information Administration, and frankly, I don't know an answer for you on this point. I admit, I'm stumped. Okay,
Let's say 44% more per capita because of industrial.
yeah, it may be that, but,
But it says households.
yeah, it may be, you know, this was lifted directly from the site. Now, I'm not gonna say, I'll try to get you an answer before the end of the night, but I just frankly, at this point, don't know.
All right, Andy Anderson.
Yes,
In all your studies, did you come across a researcher named John Goffman?
Thank you.
Do you know who he was?
no, I do not know who John Goffman is.
He was the co-discoverer of plutonium in 1942.
Okay,
And the reason I'm asking was, you know, John Goffman was, along with Alan Weinberg and a bunch of other people that got fired by the Atomic Energy Commission for blowing the whistle on what the nuclear disaster would turn out to be.
right.
And they turned out to be correct 20 years later.
Well, the funny thing about it is Alan Weinberg himself was fired in 1973 from the Nixon administration for bringing out the very thing you're talking about. He did talk to Ralph Nader, talked about the present dangers of the present day systems that we use with uranium-235, the inherent problems with the present day nuclear reactor technology, and frankly, he called nuclear power in its present day form also a Faustian bargain. It produces a lot of stuff, but it has to be watched. One thing nice about these thorium reactors is you have to keep them going. You have to keep the source going constantly through the circulation of liquids and the temperature maintenance and everything else. It doesn't melt down. It'll just drain into a tank. This present-day nuclear power, you have to keep cool. You have to prevent it from getting out of control. And that's the big difference between the U-235 reactors we have today and what I see as a furtherance of plentiful energy and the thorium option.
Bob Rosensteel.
I have a couple of questions. First of all, if the thorium reactors were such a panacea as you claim it is, why isn't our nuclear expert David Kraft screaming up and down and supporting this? Secondly, have you looked at our website, the Union of Concerned Scientists, and our studies in thorium reactors, and found out that there's really no significant difference in safety, cost, issues with the thorium reactors than there is with the current?
Yes, I have.
And the third thing would be, what about advocating more research and development on controlled nuclear fusion, which has no radioactive debris, where that one glass of water will reveal the energy supply that you claim? Those are some of the few questions.
Well, the first thing about it is David Kraft and your Union of Concerned Scientists do not understand the power of what goes on with the liquid fluoride thorium reactor. They, with the reactor itself and the design prospects, a lot of what David was saying was comparing apples and oranges. He's comparing today's technology with thorium burning in our present day technology reactors, not taking a look at these new Gen 4 reactors that they're wanting to do. The second thing, in order to address your question too, is that thorium is not a fissile fuel, it's a fertile fuel. It has to be bombarded with free neutrons, go into what they call, I think it's called it goes into another state for about 28 days, and then decays into uranium-2 U-233. And with it, in a liquid fluoride salt state, you're going to have the 233 burning with the fission products being removed off, which means basically the counterpart to the thorium reactor. And then you have to store it in the area. But the thing is, what's nice about the fluoride reactor is that the fission byproducts, the uranium U-233, which comes from the thorium, can be separated chemically and can be reintroduced into the reactor. Plus, with some of the safeguards that they put into place, you can, if power goes out at the plant, it just shuts down, shuts off. Have I answered your question?
Not completely, because
Okay.
our certain scientist staff has shown that there's no significant economic gain by recycling. That's a huge problem.
Okay.
This as well as the uranium.
The thing is
You have to-
the uranium problem, I believe, can be solved through the implementation of these reactors, which will basically recycle the nuclear waste as we have it. You see, the thing is, with present-day nuclear power, we're just not recycling. We don't have an effective reprocessing infrastructure in place. In France, they do. 80% of their power is used. There's still a lot, like I said, it's not like there's not going to be waste, because even after 30 years of successful run in a liquid fluoride power plant, you're still going to have waste products that will need to be sequestered for 500 years. You're still going to have waste products that will need to be shielded from the general public for about 500 years. But certainly, now I'll tell you something else. Compared to the carbon, the pollution that's produced through chemical means, the total amount of nuclear waste in the United States, if you put it in a football field, up to about 30 feet high is what we've generated from day one in the nuclear power industry. About maybe 10 yards of that, which is all of your long-term stuff, are there. I still think we can deal with that amount of waste that's highly radioactive than we can by burning the other stuff. I just can't see us. Now, I'm not saying that wind and solar are not bad, because they do provide, good backup power, heaters for water, certainly help in conservation of buildings. But at this point, to replace oil and fossil fuels, you're going to need much more power, much more concentrated. Now, fission, now let's go to fusion, okay? I too am aware of fusion, but fission is a hell of a lot easier to do than fusion. Fusion right now is done at the most promising developments are the tokamak reactor, $50 billion plus being spent on it, and it's still, they're saying, is another 20 to 30 years away. They've been working on this stuff for years, and I too would like to see a good fusion reactor, but at this point of research, it's not going to happen. It'll be a heck of a lot easier to get these thorium lifters running in mass production, much quicker, much faster, to provide that cheaper than so cheap it needs to be metered than it does. And plus, when you consider the benefits of electrical power that is provided to the people from these reactors, it can be done. Now, if you think we can't mass produce nuclear reactors, we're already doing it in a much more technical operation. That's called a jet airplane.
All right.
And they make them all the time and test them. And still, flight is one of the safest modes of transportation around. Okay, did I answer your question?
Well, I have a good point you made. I think other people want to talk.
Okay,
I
no,
appreciate your response.
No problem.
Al?
Yes.
Oh, Charlie had his hand up before.
Let the others
Raj
go.
is next. And,
Okay.
after him, Ruth.
Okay, Raj? Oh,
I'm next.
yes.
Okay, do you have any idea about how much Chinese per capita energy consumption is USA?
At this point, no, but I know that when we can go onto the internet, we can probably pull it up really fast.
repeat
I
the
think it's under
question?
about 2,000 kilowatts per year right now.
I'm sorry, but I don't think everybody heard the question.
He's asking how many kilowatts of power per year are being used by,
No, 1%.
per person per year in China.
Less than the US.
And it's a lot less than the US, that's for sure. But you also have to remember that about 4/5 of China's people are still under the poverty line, and their energy use is growing very fast. Like I said, they are putting one new coal plant a week online. Okay, and then these people want washers, they want electric lights, they want things. And I do know that if we did pull up the comparison, I would probably guess it would be about 2,000 kilowatt hours per person per year versus the 8,000 that's required for a prosperous
So
economy.
you're having side out of sausage and hot
Is
cake?
that Ruth Bolger?
Robert, you
Yes.
have 2 dimes and a nickel.
Okay, we got all these answers for electricity. We got thorium, we got fuels, we got coal, we got natural gas, we got wind, we got solar, we got hydro. There's all kinds of electricity options.
Right.
It's great. Gotta use all of them.
Okay,
You've decided that, right?
well, I've decided that,
Thank you.
what I'm simply saying is that a lot of environmentalists think renewables are it.
No, I don't at all.
That renewables are
Paul.
gonna be,
Here,
get
let
us
me give
off
this to
oil,
you.
and it's not. It's not. Nuclear power, particularly this form, is probably our best option for large-scale, centralized power production. And there's a lot more to it than that.
Okay, that was my first little question. Second one, okay, we're talking all about electricity. 90% of oil use is for diesel, jet fuel, gasoline.
Okay?
90% of it, most of it,
Okay.
oil. What are we gonna do about that?
Simple.
Transportation fuel.
What you can do,
You can't use any electricity for that
No,
stuff.
but the
Trucks,
process
jet
heat-
aircraft.
the process heat that comes from a thorium reactor can also be used to synthesize fuels right from the atmosphere in the form of in the form of diesel, ammonia, and other parts. If you looked at the small little part in there, there's a lot more to it than just the generation of electricity. And a lot of industrial scales, the process heat that is used can be done for a lot of other industrial purposes, including the synthesis of synthetic fuels on a large-scale production, including the electrolysis of water for hydrogen production, the synthesis of biofuels for like ammonia and other types of
This is
things.
gonna replace 20 million barrels of oil a day?
It could if the deployment of
US
the,
uses?
it could if the deployment of power plants is enough and there's enough process heat that's being used. And pending they can make money off. Remember, oil is gonna get a lot more scarce over the next 50 years, which basically is gonna mean that these process heat that these reactors could generate would be probably more lucrative than the financing of electric power itself. And not to mention too that at the end of life of these plants, there's a lot of these small fissionable isotopes that are very good for the medical industry too. Which basically means, there's a lot more to it than what I could get into tonight on this stuff. Have I answered your question for you?
Yeah, it's just that
I understand. It's
oil,
gonna-
we don't even
it's-
we can't solve oil.
Just 1 second.
We can solve,
Electricity.
we can solve it by the use of electric vehicles, hydrogen infrastructure. It's
Yes.
gonna be natural
Yes.
gas for quite a
Yes,
while because there's a lot less pollution on it and we have
Yes, honey.
plenty of it. But I honestly think that when we go to some type of synthesis of fuel by process heat or some kind of hydrogen or even improvements in battery technology that will make practicable electric vehicles, that's what's gonna finally replace the transportation fuels. Oil is a very good substance. I mean, there's more power in a gallon of gas than you would see. I mean, I just go right now, put $30 in my car for gas, I get to the college and back. I don't have to worry about charging anything. That's the benefit of fuels. Electric power, I'd have to go have the car recharged for at least 8 hours overnight. And heaven forbid if I forget to plug it in, Now, you gotta make a lot of points. It's not just electric power. It's gonna require a lot more than just, this thorium reactor being used for electric power. You can also, with the process heat, synthesize hydrogen, electrolyze water, desalinate stuff. So there's a lot more that can be done with the process heat from these reactors. And they run at about 4 times the temperature of a normal nuclear power plant, and roughly at about 2,000 degrees Fahrenheit, which basically means that electrical things. Okay, yes?
All right, Ruth Bolger.
Thank you. For the special ed kid that doesn't know how to work a cell phone, what I've gotten from this then is that thorium is not the problem in itself. It's the answer to the shortage, to the fuel shortage, to powering electricity. And it's not in the thorium itself, it's in the reactor. Am I correct on that?
Yes, the reactor design is what is going to be, that can burn the thorium up. That's going to be the answer to the problem. It's not, okay, just to briefly review, we use uranium-235 as a nuclear fuel today. It burns in a, what they call a heavy water, a light water reactor where it's immersed through control rods, through a, in a large containment building. Those rods must be underwater at all times and have coolant circulating through them at all times in order to stay cool, else you'll have what we call a meltdown. Now, only about 0.3 to 0.5% of the uranium is actually burned, and after about 18 months, those control rods are taken out and put into a pile and called waste. It is a highly efficient energy system, but still in engineering parlance, it's a very inefficient system because only 3% is burned up. Now, with a different kind of a reactor, which uses liquid in the form of a fluoride salt, which basically means they could then take all of the, and there's no control rods, there's no surface area, they can usually put that type of reaction into a, they would have roughly have like a basketball, a thorium, it would be a basketball size area of uranium-233 that's fissioning. The byproducts or neutrons from that small basketball-sized ball of uranium-233 would then pound on the blanket material that surrounds it, which is thorium-232, which would then, because of the atoms, the neutrons coming from the uranium-233, would then transmute itself into uranium-233, which would then mean thorium would, in effect, change to uranium-233, fed into the core. The uranium-233 then burns, making a few fission products, but the burn is mostly in the form of energy, and it's about, the waste is less than 1/100th of that from a conventional light water plant. Does that answer your question?
Yeah, then if that,
it's the type.
The other part of the question was, if that is as simple as you could make it so that I can at least get some idea of what you're talking about, why has it been so long? Has it been because of the bad name of nuclear? You know, it's had a bad reputation for many, many years, and justifiably so. And how would this, the thing I don't understand is how would this, the safety of the whole thing change? Was it is it going from fission to fusion, or fusion to fission, or whatever?
It's a different, because the reactor uses liquid, you generally have to, with the present day light water reactor, it's always running. It's always going. It's like trying to contain an explosion or contain the radiation from leaving. You're always trying to slow it down and regulate it, but it wants to melt down in a natural state. It wants to become a big, gigantic lump of things that need a lot of radiation for a long time. With the liquid thorium reactor, if you didn't apply power to it, you didn't circulate the fluids, it would just go down into a drain tank because of a little freeze plug at the bottom, and it would just sit there and solidify. Because these fluoride molten salts are only liquid at about 400 or 500 degrees Fahrenheit. They're not water soluble, and they kind of become crystal and solid at 70 degrees Fahrenheit. It's a lot better off to run that way. Okay.
All right. Van Weinstein.
Yeah, my question is something like that, the previous question.
Okay.
But there was, in the 30, 40 years ago, people talked about hydrogen, getting energy from hydrogen, from
Yes.
water, breaking up water and somehow. So, I mean, and this is a thorium reactor.
Right.
So, and we're using uranium
Right.
now. So,
And
what-
in effect, what we're still going to be using is not the thorium itself. It's uranium-233 rather than uranium-235.
okay, so the political people in charge, political people have decided that we're not going to change the thorium, we're not going to change the hydrogen. So what would it take to convince Congress or the President to use thorium?
I think right now it's going to take the Chinese developing a commercially viable liquid fluoride thorium reactor that comes straight on the market, and we're going to be stung in the seat of the pants again. And once they do it, we're going to follow suit and build a better one. Remember, it was Sputnik that kicked us in the rear to get us to the moon.
All right, Charles?
Yeah, Tim, on my way here on the corner of 35th and Halsted Street while I was waiting for the bus, there was a giant billboard, several times bigger than your screen, and it said this was a green sign, powered by solar energy.
No.
And it had all sorts of movies and stuff, and it seems like that's more than enough light and illumination that I need to read a book tonight or operate my computer. And didn't I send you an email
Yes, you
that a
have.
solar installation is going up, what, one every hour in Illinois?
There are, and as I said before, Charlie, I am not knocking the solar and wind industry. There is a lot of innovation taking place
So
in
you
there.
say you present it like it don't work. I need all
It's
this
not
land and
going
all
to
this,
provide
and
enough-
there's one in Bridgeport
What's the question?
on a building, didn't use up any land. So where's all the land?
Charlie, it's very simple. I agree
Is
with
he
you.
telling the truth? Are you telling the
I'm
truth?
telling the truth to the simple
You want a
fact
question?
Moderate, Ron.
that solar power and wind power are good things. In a lot of applications, they absolutely work, such as heating buildings, such as secondary generation in homes, such as, even larger scale power production in the state of California, like in a desert environment, where they actually use molten salts to power steam turbines. But the point is, it's not going to be scalable enough to get us off of oil completely. It's not going to be enough to power an entire city. It's not going to be enough.
It's enough to power a billboard.
Tim, I have a question.
Yeah, but it's not enough to power a city.
It's all right.
That's a lot of
Hey,
power.
Tim,
Yes.
Tim,
What are you
I
gonna
wanted
do
to ask
when
you,
the wind
hey,
stops
can I
blowing
talk?
and the
Hey,
power goes off?
hey, okay, listen, Tim, I noticed that you
Yes.
use,
It
I
does
noticed that you
in
use the
Las
US
Vegas all
Energy
the time.
Information Administration
Yes.
Way
as
to
a
Palm
source a lot.
Springs,
What
it
is the
goes
US Energy
2-3 times a week.
Information
They got
Administration?
the busiest, more windmills in that area.
To be honest with you, it was a government agency that produces data that I considered reliable and accurate.
Is it part of the Department of Energy, US?
That I do not know, but we could look it up later on and find out.
This is a branch of the federal government.
Yes, it is.
Okay.
All right, David
You don't have
Zucker.
to do it.
Where do you stand on the question of fracking?
You should. You should get a big tip from everybody.
Fracking right now, to me, it's environmentally damaging.
Thank you, Rob.
It has the potential to
Oh, thank you, Jean.
clog our waters and our streams, and I agree that if we adopt it on a wide scale level, we're gonna be in big trouble. I don't like the fact that we're taking out our tar sands in Canada. I don't like the fact that we go down 5,000 to 6,000 feet underneath the ocean floor to find oil. And that the only way that I'm gonna see a replacement for oil is through something like these thorium reactors. And I mean, I am sorry, but you know, a lot of times when you have an oil economy like we do, and a coal economy like we do, we're burning this stuff. The fossil fuel companies are getting more and more creative, and if they're not out-marketed by a cheaper source, they will burn up every last bit of oil we have, and there will be more greenhouse gases into the planet because we're not going to stop the development of power to the people. Developing countries are going to demand that they have the same level of power and standard of living that we do. And if we're not careful, we are going to run out of those fossil fuel resources. And fracking, from what my understanding is a little bit on the
Dangerous.
dangerous side. So I'm with you on that. I'm with you on a lot of these environmental causes. It's just that I could not see a way out. One of the main reasons I'm being a proponent of these molten salt reactors is because, yes, any type of fuel that you use is going to produce some kind of waste. But when I look at this much stuff being used to power your whole life, rather than something else, the argument for me is this. We cannot afford not to do the thorium option.
Oh,
Because what is, the alternatives are crazy. Now, I don't think, as I said before, wind and solar are making a lot of inroads. But they're not simply going to provide enough power to get an advanced industrial civilization going. Here's the other thing, we're not going to run out of this stuff. There's a 5,000 year supply on the Earth, and we can already see it on the moon, stars. Once we commercialize this stuff and get it running right, we have got our energy crisis solved.
Hey, let me know where it's at.
It's common. This probably, yes, Andy.
Do they have the insurance companies up in place and the Wall Street investors to both insure and back them with private capital?
Not yet.
Why not yet?
Probably because the investor capital community will not finance this stuff because it's too risky. It's still, you're still going to need some government involvement to get the basic first cost reactor done. And once that first cost reactor is online and viable, say China, for example, produces the first liquid fluoride thorium reactor, and they're starting to make power, you can bet you real quick that Wall Street's going to find a way to build them themselves if they can make money at it.
All right, it is up. It's now 8 minutes after 8.
And I think it's time that I know you guys have a lot more questions, but I think it's time we all move to rebuttals because I know a lot of you are chomping at the bit.
I know you have remarks. I'd like to see the hands of people who have something to say. 1, 2, 3, 4, 5, 6, 7, 8, 8, 8, 8. Maybe even 9. Okay. All right. And then, of course,
I'll follow up.
we'll have the
Don't take the
last word.
forensics,
All right, David Travis.
New of
Now,
it.
boy,
And bring this up.
I think Karina has another question.
Forensic sounds like a body.
Push the power button. Now again.
All right, let's thank our speaker. Why don't you take down your screen?
Okay, yeah, I'll take it.
It's gonna fall down.
Okay, I'll be back in a minute. Charlie.
Let's see. About how much time?
Go about 4 minutes each, Brom, 4 to 5.
4 minutes each.
You're not allowed to make any sounds when David speaks.
Okay, let me get a timer going here for you.
Good evening. I'm David Travis. Tim downplayed the use of natural gas, but natural gas will be increasing dramatically in the near future because of the miracle of fracking. It used to be when they drew. Hello, can I please have my say, sir, and then you can talk when I'm not talking anymore? Will that be okay with you? It used to be when you drilled an oil well, it was a hit or miss proposition. Today, virtually every oil well they drill is a hit for oil. And they have this thing where they do horizontal drilling. And then they make explosions in that, and they break out the natural gas via fracking. So energy in the way of natural gas will be picking up drastically. Oil will be picking up somewhat. This whole thing reminds me of a joke I once heard about the about how many libertarians does it take to screw in a light bulb, and the answer is it doesn't matter because the free market will take care of it. I think that we should confine liquid fluoride to being put in toothpaste. And in case I'm wrong about the free market, which I don't think I am, there is another solution that a gentleman in this place has, who unfortunately isn't here tonight. But we can take and have all the energy that we need just by burning all the plastic shit that's in existence.
I have also done a little study on the subject of thorium myself. The one popular question is why is there no thorium today? Well, back when they were doing the research, Alvin Weinberg himself thought that it was such an obvious choice
Broccoli or chicken noodle?
that he never really pushed it. He said, this is the obvious choice. And it, but with our government, the obvious choice doesn't always win. Back in the 70s, when the plug was pulled on the liquid reactors, as Tim said, thorium was in Tennessee. Uranium was in California. President Nixon and others from California wanted jobs in California, not in Tennessee. And today, the nuclear power industry is so entrenched, and there's so much money to be made in it, as Tim said, that it would be politically unwise for anybody to go up against it. Here's something that Tim didn't mention. Since you don't have to have containment, since it's not going to blow hot steam all over the place, and you don't have to have cooling, since it's self-cooling with the liquid fuel, these plants are much smaller. You could put a small thorium plant on a semi-trailer, which means you can have power to go. Think about a natural disaster like Hurricane Katrina, wouldn't it have been great if they could have just rolled in a couple power plants on the back of a truck? Think about the military. Don't you think they would love to have electricity to go? And I think one of the best things about thorium is in a fission reactor with uranium, solid fuel, you remove the fuel, it keeps going, it keeps burning. That's why you always have to constantly try and stop it. Because if you don't stop it, it's going to go and get bigger and bigger and bigger and melt down. With thorium, if you remove the fuel, it stops burning.
Tim's check is paid for, will be paid for.
Which is why if you drain it off, you drain off the liquid part, the core itself just burns itself out. And that's why it's safe.
The speaker doesn't pay.
Thank you.
The speaker doesn't pay. Black Forest? Let me get you. Janet?
First of all, I want to express my appreciation to our speaker tonight who put a lot of interesting issues on the table. I like his notion of a Faustian bargain. I think that has to be looked at in the context of every form of energy proposed. It wasn't that we were talking, that has nothing to do with my agreement or disagreement. We had profound disagreements on many aspects. I'm deeply concerned about in this thorium issue. Our staff at the Union of Concerned Scientists have found that there's a great deal of problems with reprocessing of any type of nuclear fusion. There are no economies to be saved, whether it's thorium or with the conventional nuclear fission process with uranium. Also, I'm deeply concerned with the nuclear waste that would come out of this in countries other than the United States and maybe Western Europe, where we don't necessarily have safeguards against terrorists. And Dr. Rosner, I think in debating, who's the former director of Argonne, pointed this out, that is one of the problems with bringing additional types of nuclear fission plants abroad, that you don't have the safeguards that we would in the United States or maybe Western Europe, and there could be purloining of some of the residuals if, in terms of possibly generating bombs. The areas which I'm in very strong disagreement with Tim concern the fact that about the scaling up of renewables, wind, solar, geothermal, and hydrogen. First of all, with the hydrogen, I think we have to go to seawater or contaminated water because we're having depleted sources of fresh water. And even if we do electrolyze water, we're going to rob Peter to pay Paul. We need to keep our dwindling supplies of fresh water for other uses. The hydrogen can be generated, and we're working on that strongly in the research community, doing it from seawater. I can recommend going onto YouTube and looking at Harry Gray's Powering the Planet with Solar Fuels in 2009, where he has introduced the idea of using seawater with protections for corrosion. This is one way to get the hydrogen without depleting our dwindling sources of fresh water. Now, in the area of not scaling up solar, I think that is not correct. We're developing more efficient devices for converting solar energy into electricity with new materials and new types of photovoltaics coming on. And also the electric grid has to be restructured. And one thing we're working on very strongly is these smart grids, which will be able to store and transmit energy over very long distances. Now, for example, the wind farms 100 miles away from Tim's house, if we were able to develop these smart grids, and with the superconducting materials that we're developing, this will enable us, I think, to realize that goal of storing and transmitting the energy. And that will be one way we can scale up on a much larger effort these carbon neutral renewables. So I disagree very strongly with that point, and many people in the scientific community do as well. But he's right now, the current technology doesn't permit renewables to come online much more. And the final thing I would advocate is for a carbon tax, because we're subsidizing a lot of the fossil fuels. And if we can get the carbon tax and cut out the subsidies, we can put a lot more money into the scaling up process with the grid development. And I'll just close by saying that one of the unique methods I heard was based on space-based manufacturing. Dr. Peter Schumer, who directs the Richard R. Lugar Center for Renewable Energy at the University of Indiana and Purdue, has patents to manufacture photovoltaics on the moon. And he's working with NASA on that. NASA is very interested in this because there's a lot of pollution in conjunction with this. And that comes up to Tim's good point about the Faustian bargain. If you build a lot of these photovoltaics, there's a lot of environmental pollution. So these are things which we have to consider. But the Faustian bargain, I thought, was the main, very good point that Tim brought up in his speech, and we have to keep that in mind.
Thank you, Jane Anders.
I was just about to raise my hand when they cut the question period. And my question was going to be, and maybe Tim can answer this, and I had to ask you, because every time I hear somebody say that we're going to run out of oil, I get that faint feeling. It doesn't make sense to me at all. It's almost like somebody saying, we're going to run out of the atmosphere, we're going to run out of the sun, we're going to run out of the water. Well, I got news for you. You didn't put the shit there, and you ain't going to use it all up. Now, they told me, and the people that spread this propaganda, I can't believe them, even if I didn't know that there was a water and an atmosphere and a sun that we all need to live. But when I heard them say that the oil is there because the dinosaur died in this dinosaur oil, and we got a vegetation that is under the ground that created this oil. How silly can you get? And these same types say, oh, the dinosaurs died because a big rock hit the earth and some smoke went up and blacked out the sun, and the dinosaurs didn't have nothing to see, so they died. So I'm saying, please tell me how I'm supposed to believe the person that gave me that information. And those are the types that say, we're going to run out of oil. Well, I got news for you. The oil companies, obviously, behind this, because ever since I was a little boy, I have heard of oil depletion allowance. The oil companies say, we're going to run out of this, therefore you got to give me some money because this is shit going to run out. Well, I said, man, give me a break, please. Now, I got to thinking. I was a teenage little boy in Mississippi. By the way, they had oil wells in Arkansas, Oklahoma, Texas, and so forth and so on when I was living. Yeah, right. So I'm saying, well, gee, if this is the case, it must have something to do with this money that the government's getting the oil companies that claim they need it because this is going to run out. Give me a break, please.
The answer to your question is, look at the data. The answer to your question is, look at the data.
Very good.
Well, that's what I said. The data was made by them.
I'm still putting together a letter to Charles Koch on the difference between a free and a, quote, free market, which touches upon a lot of issues we've discussed tonight. I thought I'd have it last week, but had a few snags. I'll get it eventually. But if you want to give me your emails before you go tonight, you'll get it sooner or later, and some other things too. If you can put a thorium reactor inside a semi-trailer, you can power a train with one too. And maybe that's the way to power the new generation of steam locomotives. I can still use a ride home tonight. Anybody?
Instead of having a coal car.
Okay, go ahead. Raj Patel.
Raj Patel.
I spoke on this subject about 7 or 8 years ago here, and I had lots of opposition with them that I am for everything. You know, let's do a research and everything, and let the market, investors decide everything. Government make sure the regulations and safety standards are right, and let's move on. You know, but if you say one thing is right or other thing is wrong, there is a problem. Tim was doing very well until he got into this thorium thing. See, technology is such a complex thing that we cannot, I don't think we are capable of deciding it here or discuss it even just such a complex subject, except peripherally. And if China is going to do a thorium reactor, wow, it's a great news. Let them do it. Then we'll follow them. What's the big deal? You know, I'm happy with that. You know, let somebody else do research for a while. We have done lots of research and they followed and they used it and we will use their research. That's great. I don't mind it. The difficulty we have is we have lots of other problems besides energy. The problems we have is that we are not able to complex it in our society, and we are messing up our moral standards. We are getting too moralistic. The case in point is that guy on NBA, that Sterling guy. Okay? No, Sterling guy, maybe he's a crooked character, he's not good. He's a black girlfriend and and he's black players, and his wife, and he doesn't like his wife, and he's not a great guy. But the guy who built such a big company to treat him like a garbage in just such a small way, I don't think it does any good to America. When somebody succeeds at something, and just throw away for this thing, and believe me, racism is a problem. Racism problem not going to go away just like that. Racism problem is going to go away when black community decides that they are going to get educated, they are going to improve, they are going to build businesses, and the community is going to support black on black. If they are going to, they want freedom, they want equality, because white people are going to bless them. I do not believe it. My freedom doesn't depend on a white community or any community's blessing. My freedom depends on my own. And I think the black community has to realize, nobody in the black community is saying I have heard about, public, including president, saying to kids that go to school. Okay, let's decide that people, let's take kids to school, everybody. Let's organize that. Okay, let's teach the kids not to have kids. Okay, the white girl can have a baby and she can maintain it. Black kid have a baby, black girl have a baby, then her fortune is gone. She's screwed big time. So let us do that. And we are not doing what we have to do, and we are, same thing, I think Barack Obama did a very nice thing, give a speech on using our force abroad. Because we have used too much forces everywhere, nobody likes it. Europeans don't like it, Asia don't like it, Africa don't like it. We are spending so much money on invading countries. Gosh, it's crazy. I mean, we spoil our economy. Just fighting wars. That's crazy. Thank you.
What's wrong with fighting wars? You gotta kill some Americans.
There was a war that ended the Great Depression.
Kill your enemies.
I'm not quite sure what the subject of Donald Sterling has to do with the issues of renewable energy, but since that came up, Donald Sterling brought his problems on himself. For a guy who ran a business that depended in large part on the successful talents of a lot of people, most of whom were of African American descent. It was rather dumb and thoughtless to have made the statements that he did. And when you further throw into this that in addition to the NBA, he's like, from what I have been able to understand, Los Angeles' biggest slumlord. Well, seems like this is a guy who was overdue for a fall, and all that happened was that somebody pulled the rug out from under him. Well, bravo.
Thank you, sir. Appreciate it.
With regard to the...
Get 8 years old and tell it again.
With regard to Tim's talk, which I thought was very well presented, and I agree with some of what he said. Not quite all of it, but I agree with much of it. I'm not willing to follow him down the path of thorium, but that's more because I lack the technical expertise to do that, and less because I disagree with it, and I'm waiting to see what those wizards at the Nuclear Energy Information Service at like Steve Kraft and Dennis Nelson have to say about all this. I would like.
Yeah, I'm afraid
Oh yes. However, I remain dubious about the subject of nuclear power in general. I can recall back in the 1970s when I was in high school and Commonwealth Edison brought the Zion nuclear power plant onto line. And they promised us years and years of cheap electricity and had that little light bulb bird character, little Bill on those TV commercials. Little Bill! Well, it hasn't gotten any littler, it's gotten, if anything, it's gotten bigger. Apparently, ComEd figures that the less littler it is, the better for everyone. Finally, we heard Gene talk about, earlier, the comment, we heard him talk about his belief that that these resources that we have will run on forever and that we're not going to run out of anything. We've been talking about that since I was in high school too. That, I'm sorry, these resources are not limitless. We will eventually run out of oil, and the oil depletion allowance, which is a gimmick put in there to protect the oil industry, that's not got nothing to do with it. We will run out of oil, and we are messing up our atmosphere at a rate faster than we are going to, it looks like we are going to save it. And global warming isn't simply a theoretical possibility, it's already here. Thank you.
Hey, one for little Bill, huh?
All right, let's thank our speaker. Again, I'll be eclectic here as usual. I'm sorry I didn't catch the community where you live, Tim, but I think you ought to make some efforts instead of this, what was that, is quixotic a term? Don Quixote, quixotic pursuits, and try to create, what I'm trying to do in my neighborhood is make it a sustainable community. You bemoan the fact that there's 100 and some miles to the closest renewable source. We'll do something about that, sir. Okay, the other thing is, thorium is, and I mentioned this before, in the periodic chart of elements next to radium, which I believe killed Madame Curie. This is not the benign substance that I think you're conveying it to be. Also, I'm a little suspect about technology. I'll get into that. You say, I don't, what's this thing? Well, the last time I've heard, this is not proven technology. So right there and in there, about 80% of what your assertions you make, I cannot be substantiated. The closest you'll be is at least 10 years away from the first smallest workable radium reactor. So anything you state about this process is dependent upon getting one operational. And I've also spoke before here many times. We had a fellow at Ponder who came here, and he was working on his machine that was much even better than thorium, because you could just throw an old couch in it, turn it on, and then you'd get a gallon of gasoline at the other end. Amazingly enough, sir, he had two versions, an industrial size, and he had one that would fit in your home, which he was working on. This was going to be a home version. The other thing I was reading here, under the solar-powered sign while I was waiting, was I'm a transportation guy. I was reading this book about the history of railroads, and they have a whole chapter here on heroic failures. Technology that didn't work. Even by one by Isambard Kingdom Brunel. Some of you may know who he was. An engineer put together the Great Western Railway and a big first iron ship. And he went bankrupted the British government and shareholders of 400,000 pounds, or about $55 million, making an atmospheric railroad, which didn't go for the 11 miles it was going to go. Talking to Congress, there's any number of people who show up looking for venture capital, and they have solutions to the government's energy problem, and they want the government to write them a big check. And this will, and they better do it because the Chinese are doing it or something like that. But there's all kinds of guys who show up with plans in Congress regarding that. This other thing, well, if our machine malfunctions, we just shut it down. Now, I vaguely recollect my limited knowledge of nuclear technology. If your nuclear reactor didn't work, you just pull the rods out of it and shut down, right? Well, when are we going to shut down Fukushima, if ever? This is modern technology. A nuclear reactor. This isn't built by some crazy Russians here. These are written by the Japanese. They turned an entire portion of their nation uninhabitable. It's spewing stuff into the ocean, making that dead seas. Look at this stuff carefully. There's a lot more to energy policy like this, like green building technology like this, stuff like this, off the shelf right now, instead of this stuff that, to me, I don't know. It's like the guy that said, in 1890, in 5 or 10 years we'll know how to fly. Anyhow, thank you very much. Is this mine? All right.
All right. Well, Tim, I was impressed. You sound like a climate change believer. I am. That you want us to get us off coal and oil. So, but I think most of the green people, the learned, knowledgeable green people, think that I think you got to have a combination of everything. And there's so many abundant sources for electricity. I mean, we have 1,000 years worth of coal. It's coming from everywhere. So I'm not that worried about electricity and the other sources that we can produce it. There's plenty there. Problem is oil. Oil is continuing to grow. And this gentleman here, here's your rationale that we're out of oil or we're gonna run out. Why in the world would we go to the North Pole or go 5 miles under the Gulf of Mexico or tear up all of South Dakota? There were 2 programs here on how much we're tearing up the environment, digging up gold, oil, shale, sands. It's a disaster. And it just started, baby. Because Halliburton and Dick Cheney just got it going. That's going to be a vast wasteland. Half of Canada and all the Dakotas. It's going to be a disaster. Yeah, well, forget about it. Because it's all going in our tank and in the Boeing's planes. So, I think the problem is oil's going on and on. There's not a real substitute. Maybe these thorium reactors that have other adjacent devices can produce oil through hydrogen, somehow, some kind of jet fuel. I doubt it.
Careful.
But I think for the
A1
time
sauce is
being,
coming.
you're going to see a lot of these trains coming through Chicago. And you're going to see a lot more of these trains come to Chicago. And the pipelines aren't going to get built. And so we're going to see more trains coming through Chicago like this. I grew up in Brookfield, a block away from the Burlington Northern. And I have buddies there, and they say that town rumbles a lot. And the day that Naperville burns up, or Hinsdale, or Barrington, from oil shale, or whatever, this is all, what you're looking at here, folks, is jet fuel and gasoline. But when those towns burn up, like Quebec burn up, then things are gonna hit the, you know what's gonna hit the fan. So again, since we have plenty of electricity, the New York Chicago bullet train runs on electricity. They do it all over the world. Once we get sustainable, we get thorium online, our trains can run on thorium, as well as wind, as well as solar, as well as hydro, as well as nuclear, as well as coal, as well as everything else. The bullet trains, electric bullet trains, are sustainable. Thank you very much.
Thank you, Billy.
We have 4 minutes, right?
4 minutes.
I'll keep a timer here so I can tell I don't run over.
20 to 9.
Here's a
Time.
concept of energy, solar energy. You get these things for $20 at IKEA. Little solar panel lasts for years. You leave it out in the sun, charge it up, and then when you want light at night, it'll run for 6 to 8 hours on one charge. It's a reading lamp.
That's a trick.
That doesn't have to have a line running miles to a pole or a power station or anything else. You collect the solar and use it right where you're at. There's a solar rooftop revolution going on that tonight's presentation and the people that promote thorium completely downplay the solar revolution worldwide by a factor of about 10, for one thing. What we're seeing with the thorium alliance, as far as I can see, as I've talked about, Americans in this country, Censored News, Project Censored, describes the process by which the media maintains us in a bubble of what one guy says a Disneyland of militant ignorance. That's America. Americans believe things that are 180 degrees out of phase from observable, proven, accepted reality all over the world. The nuclear power issue has been settled since 1980. That's why we don't have 1,600 reactors of any kind running. We had 104. Their credibility was blown away before 3 Mile Island happened. Central nuclear power plants are the ultimate Trojan horse. Any country running, depending on central big stations, can be eliminated with a dozen compact portable atomic nuclear weapons. You blow up a dozen big central nuclear power stations and the country becomes a giant mess. They've been hunting for terrorist nuclear bombs in American cities since 1975. They decided, don't tell us about the hunt until the day we lose a chunk of a city. When we have a first terrorist blast, then they'll tell us that there's a problem with the whole entire nuclear power infrastructure, because that's where the bomb material comes from. You know, if the fellow with the glasses, Kirk Sorensen, was here tonight, I would ask him a question specifically to his face. I'd say, you're in one of 3 categories. I want to know which one it is. Are you terrifyingly ignorant of world reality? Are you certifiably insane? Or are you an intellectual prostitute paid to stand here and lie to us and give a great speech? It's one of those 3. Which is that presentation put on with the guy with the glasses is such a smooth presentation that ordinary, kind, decent people that haven't read 100 books, like Tim and millions of others, get sucked into it. Like I got sucked into it thinking nuclear power was the greatest thing since sliced bread back when they were talking about Little Bill and the peaceful atom. Then the current drive toward thorium has nothing to do with energy.
It has everything to do with slowing down the spread of solar, wind, all kinds of alternatives that will cut into the profits of what is known as King Kong. Coal, oil, nukes, and gas. That's what a lot of the solar books refer to that whole megastructure as King Kong, and they're fighting back. Gandhi said it best. First they ignore you, then they laugh at you, ridicule you, then they fight you, and then you win. The current report out of ComEd itself says by 2015, 2/3 of this country is going to have cheaper solar access to solar electricity right off their roof by 2015. So this is not some debatable issue. It's happening, and the Thorium Alliance is simply doing what they can to slow down the spread of it to keep the profits flowing to coal, oil, gas, and nukes. And also, ask yourself one final question. For those of you that have computer access, log on to the Solar Decathlon. It's college contest. They build 800 square foot transportable houses that are powered by light. Light-powered houses that have no utility lines coming into them. They're being built and shipped all over the world. We'll talk about this more on July 19th. And also the update coming in September, an update on September 11th. We're going to talk about the alternatives. Bring the troops home from everywhere and spend that money on solar and everything in America. We can transform the country that way, very fast. Thank you for coming.
Yeah.
Charlie, I forgot how annoying you are.
Like to know how many here are preparing another speech?
Go ahead and get up, Mr. Travis. We got to hear from you.
I would like to add,
Yeah, let me do that. I like this. I mean, I'm not sure we can do away.
it was 50 some odd years ago that I was arrested outside the Soviet legation to the UN after they exploded their 50 megaton fusion bomb. I was then a member of the Young People's Socialist League and the Student Peace Union, the Committee for Sane Nuclear Policy, a seminarian.
You belong to all the right.
But we didn't discuss nuclear power that much at seminary, though many of us were peaceniks. And when the seminarians got together, we did discuss some questions about the just war and all that. Because it was the Vietnam era, which dragged on and on and on. And the question of why nuclear power was developed was partly, historically, it was developed for a nuclear weapon and weapons. And we're still doing that today. And I think that one reason the government is pushing the continuation of the uranium is that they use uranium for nuclear weapons, and they are keyed to nuclear weapons, and they even like the uranium casings on the kind of shells that they are firing in these low-grade wars, the Middle East, and the bombs that are dropped in maybe the Balkans, that sort of thing, has its own dangers. And Tim didn't get into the hazards and costs of the nuclear industry, which may outweigh those, even with thorium, of
You're welcome.
the more, what shall I say?
Did you see your little tree?
Less nuclear
That's dangerous.
sources of energy, although you did mention the cost
More water, coffee?
of
All right, I'll be right back with your check.
the products of coal burning. I think it's important that we look to all the uses of any power source.
I appreciate it.
And I don't know how much we're going to be able to push the development of any power, but for one reason I
Yes, my friend.
think that
I give you change.
you have to watch
Time.
capitalism is that it tends to promote production for profit rather than the health, safety, and good use of any product. Okay?
I got you something.
You read my report from Russell too?
Yes, I even sent the Student Peace Union a check for, I think it was $25 when I was secretary.
Now, we've had a couple of guys get up here tonight and talk about Little Bill. One of them was Andy Anderson. And another guy named David Zucker talked about Little Bill and did a parody on it. But none of them got it quite right. It went like this. Electricity costs less today, you know, than it did many long years ago. Tweet, tweet, a little birdie told me so. Little Bill.
All right, let's remark.
Is that it?
Yeah.
You're not going to give any final remarks?
You do that.
Hey, I'll,
Well,
I loved it. Did you sign my petition?
One of the reasons that I'm still sold about thorium is because of the data,
Libertarians.
because of the potential solutions of the problem, because of my in-depth research.
Just so they could be on the bill.
That's right. Oh,
If you think there usually is no middle ground
Don't want you to sign another.
on nuclear power,
Okay, thank you very much.
it's either, the claims are either fantastic or utterly preposterous. Therefore, I'm just going to say this in conclusion. I invite all of you to go to the Thorium Energy Alliance website, check out the data, look at the videos produced by Mr. Gordon McDowell, look at some of the anti-nuclear sites too. You will not see some real outlandish modes in this technology. Like I said, you will either be fantastically overwhelmed, or you may still think it's utterly preposterous. My point in this speech tonight was to tell you that renewables are not going to cut it. I think I made that case. And the only thing that I can see to really get us out of climate change and all this energy debacle is this thorium reactor. So again, check out the data, look at the websites. You've got more things to look at and think about tonight. Hopefully, I've stimulated your interest. Thank you very much for listening to me, and I wish you all a good night.
Thank you all for coming. I hope to see you.